Okay. So see here, so electronic design automation. So that means here, if you see, so why we are doing this EDA company? So we are we are running a tool, no, like Cadence, Meta Graphics, and Synopsys. These are nothing but tools. Okay, Xilinx, Vivado. Okay, so why we are going with these tools means suppose. If within an IC 100 transistors or 1000 transistors are there means manually we can do the layout or we can design those, but some millions of transistors are there. Okay, so manually it's not possible to test that and to in order to verify that. Okay, manually it's not possible. So their tool, we need to use the tool. Okay, so tool automatically it will not work. We need to give some guidelines for the tools. Okay, so based on that it will work. I think for the front end you have some tools, VLSI front end some tools, and back end you have some tools. Okay, so basically we are using in the back end for the PD we are using Cadence, Innovus tools, and some Metagraph tools and Synopsys tools also there. So mainly we will train you in the physical design in Cadence, Innovus tools. So the companies, EDA companies, these are the companies. Okay, the companies, they will provide the tools. Okay, electronic design automation, EDA tools, or CAD. CAD means what? CAD tools also there. Computer aided design. Okay, so these are nothing but EDA companies. Okay, so now you got an idea what are the types of companies you have in the VLSI or semiconductor companies. One is product based company, service based companies, and EDA companies. Is it fine? Shall I move forward?
Yes, sir.
Okay. Next. So coming to the physical design flow. So physical design flow, if you see, first any customer or any client is there, he will come up with a specification. Okay, he will come up with a specification. So specification means I want based on this application I want, so I have this many inputs and this many outputs, so I want this application. Okay, so they will come up with the application. Okay, so they will come up with the application, that is nothing but what? Specification. Okay, specification. After specification, so who are the designers? First they will do the architectural design. Architectural design means what? So they, based on the functionality, so they will take what modules we need to use, and what are the, how many types of inputs are there, how many types of outputs are there. Okay, so they like it's like a planning. Okay, they will do the architectural plan, and after architectural plan they will do the functional and logical design. So functional and logical design means basically they will write the program in RTL. What is RTL? Register transfer level. Okay, RTL is nothing but register transfer level. So basically they will write the program in Verilog. So Verilog means what? Hardware descriptive language, no? HDL is hardware descriptive language. So here I think you studied about digital circuits. So to describe that hardware, we have a programming language, that is hardware descriptive language. So these are nothing but RTL designers. They will design this so based on these specifications. After designing, you need to check, no. So you need to check that circuit. You need to verify. Suppose half adder is there. Half adder means how many inputs are available. So you know the truth table of half adder, like 0 0. You are getting some 0 carry 0 0 1. So you know the truth table, but how the circuit will know? So that means we need to go for verification. Verification is nothing but you are using mainly system verilog or UVM for design verification. Okay, circuit design. Okay, verification, and after that you have some DFT concept is also there, and next synthesis also there. Synthesis is nothing but we need to convert whatever the program into gate level netlist. Okay, that is nothing but synthesis. Okay, and circuit design. So both the designing and verification is comes under what? VLSI front end. VLSI front end. Okay, front end people will design this. Okay, RTL designers will design, take the specification, and they will do the architectural design and functional logic design. That means here in functional logic design, you will get a simulation, and as well as designing and verification also you will get, and they will design. Okay, so that means input for this backend engine is nothing but gate level netlist. Input for physical design is nothing but they will produce from netlist, gate level netlist. Okay, so gate level netlist, and they will give it to the physical design. Okay, so what the physical design engineers will do, they will take the input. Suppose I will tell you with one example. Suppose suppose if you want to, like, if you want to construct a building, first what you need to do? First you need to do what? First you need to do what? You need to do like planning, no? So you need to do planning. That is nothing but so first you need to do partitioning. Partitioning means, suppose I'm constructing some double bedroom flat. Here I need to get here I need to get bedroom. Here I need to get washroom. Here I need to get kitchen. Okay, so that is nothing but we call as partitioning, and we need to do the floor planning. Okay, so you need to do. So whenever you are designing any chip, so means here I need to get ALU, here I need to get like some other module like FPGA, like some other I2C module or CAN module. So we need to do some planning. That is nothing but floor planning. Okay, floor planning. Do you understood what I am telling? Just to give response. Hello. Hello.
Yes, sir.
Yeah. So next what is next? Next is power planning. You need to do some power planning. Okay, power planning. And next you need to do placement. Placement means what? You need to place here some modules which should come, and here some module should come. Okay, you need to do the placement, and you need to do clock tree synthesis. Routing is nothing but what? You need to do the wiring after after floor planning. You need to do some placement. Okay, placement is nothing but placing these modules at a particular place. Okay, and you need to do synthesis, that is clock tree synthesis. Here some static timing analysis will come. You need to do with some delays in the circuit, and you need to do some routing. Routing is nothing but connection and timing closure. Okay, so all this will be done by the physical design engineers, PD engineers. Okay, total backend will be done by physical design engineers. After designing, again you need to do verification. In the front end, you need to do verification after designing this any digital module or any system. You need to do verification. That is done by whom? That is done by verification engineers, that is DV engineers. Okay, we call it DV engineers. Here also, again after doing all these things, you need to do the verification. Why? Because before going into the chip, okay, so you need to do a verification. That is nothing but physical verification. That means you need to check for each and every block whether it is working properly or not. Okay, after verification is completed, you need to go for sign off. Okay, so that is we call as GDS3. Okay, GDS2, that is nothing but a graphical design system. Okay, GDS2, and you are giving to fabrication. Okay, fabrication, there are some steps are there. So you need to do CMOS fabrication, and next after fabrication you need to do packaging. After packaging also, again you need to test whether your module or your IC is operating based on the system specification or not. Okay, and the chip finishing. Okay, so this is the ASIC design. Okay, so this is the flow, physical design flow of ASIC design. Okay, so I want to ask what is the difference between ASIC and FPGA? Can anyone say what is the difference between ASIC and FPGA? Hello, do you have any idea about ASIC and FPGA? Hello. Yeah, I'm asking anyone give response. Hello. Nobody is responding. Okay, I will tell you. So ASIC is nothing but application specific integrated circuit. Suppose if you want to do for only any specific application, we will use ASIC. Okay, so if you want to design for any specific application, you will use ASIC. Okay, so that is semi custom design. So that means only for particular application we can use. Okay, FPGA is nothing but field programmable gate array. It consists of some lookup tables. Okay, so this is reconfigurable. Reconfigurable means what? Suppose if you want to design any RAM, okay, so you will write the Verilog code and you will synthesize and you can port into the FPGA. You can port it into the FPGA so that your FPGA will work as RAM. If you want to design a RAM, so you need to write the Verilog code and test bench for this FPGA, and based on this your requirements, your FPGA will work. Okay, that is the difference between ASIC and FPGA. ASIC is nothing but full flow from the specification to the chip, wherever your chip is coming, that is nothing but ASIC. Okay, whereas FPGA is nothing but it consists of some board. It consists inside there will be a lookup tables. Basically we will design the lookup tables by using mux. Those are reconfigurable. That means we can fuse, we can program that FPGA. So we can use that FPGA as full adder, or we can use as a serial adder, or we can use that as a FSM melee machine or more machine. Okay, so that is reconfigurable. That means we can configure, we can use for R&D purpose. Okay, do you understood what is the difference between ASIC and FPGA? Just give response. Please give response. Hello.
Yes, sir. I understand.
Understood? Okay. Shall I move forward?
Okay.
Yeah. So next, if you see, so this is ASIC flow. See here, this is nothing but a physical design flow, PD flow, and this is nothing but ASIC flow. So see here. So first, as I told you, like what is this? This is nothing but design specification. Whoever the customer or client is there, he will give some specification. Okay, so I want this type of application. This many inputs are there. This many outputs are there. If I am giving this inputs, I need to get that outputs. Like that, design specification customer or client will give. Okay, so we'll take the input from the customer and client, and we'll do architecture. Okay, we'll do architecture means what? We will decide what modules we need to use. Okay, so what modules, whatever the modules we need to use, like that. Suppose customer want ALU. Okay, so customer want this 4-bit ALU. So 4-bit ALU means from that I can decide that 4 inputs are there, 1 output is there, and ALU means what? It will design what? Arithmetic and logic unit. No, it will perform arithmetic and logic unit. So arithmetic and logic unit means what? So for addition we want some 4-bit parallel adders are required. Okay, for subtraction also 4-bit parallel adders are required, and multipliers also full adders are required. And next, for logical operations also we need like AND gate, OR gate, XOR gate, XNOR gate, NOT gate, buffer gate. So total I need to, so he is telling that I want to design 4-bit ALU. Okay, so 4-bit ALU. So 4-bit ALU means from this I will decide how many modules are required. Okay, so after that, micro architecture, I need to do some architecture. This is nothing but micro architecture. So I need to do some planning. Okay, so what I need to do, so where so micro architecture means this is one type of we can call as schematic. Okay, schematic. So schematic we can do the micro architecture. Okay, after that you need to do RTL design. What is RTL? RTL is nothing but a register transfer level. What is RTL? Register transfer level. Okay, basically in VHDL there are 2 languages are there. Oh, sorry, in HDL there are 2 languages are there. Can anyone say what are the languages you have in HDL? HDL there are 2 languages are there. One is what? VHDL, and next one is Verilog and VHDL. Okay, Verilog is nothing but a very high speed integrated circuit hardware descriptive language. So this VHDL mainly used for defense purpose. Okay, they used it in the defense purpose. They invented around 1999. They came into the market around 1999, and it will follow like ADA and Pascal. That is the old languages are there. That means code will be complex. And Verilog is nothing but this is a verification language. They invented around 2000. We in the corporate or in R&D sector will use mainly will use this Verilog, and this will follow C syntax. Okay, some flows are there like data. So how to write the programming? that different types of modeling styles are there, no? Structural modeling, data flow modeling, and what we have, behavioral modeling, gate level modeling. So if you are writing the programming, data flow modeling and behavioral modeling, that we call as RTL design. Okay, so that modeling if you are writing, that will be converted into what? That will be converted into synthesis. Synthesis is nothing but that will be converted into gate level netlist. Gate level netlist. That means our circuit is in terms of what? Gates. Suppose if you want to write the program for half adder, okay, so you know that if you see the half adder, it consists of what? XOR gate and AND gate, no? So you can implement that with NAND gates, no? So internally it will be converted in terms of NAND gates and connections, that we call as gate level netlist. So synthesis will convert whatever the half adder into gate level netlist. Okay, so next, as I told, after, so whoever the RTL designers are there, they will design this. RTL designers are there, they will design. After designing, whoever the DV engineers are there, design verification engineers are there, so what they will do, they will verify this design. Okay, suppose you wrote the program for RAM design. Okay, so they will give some inputs by using test bench. They will verify this circuit. Basically they will use system verilog and UVM. Okay, so for RTL they will use which one? Verilog. Okay, they use verilog for designing circuit, and for verification, RTL verification, they will use system verilog and UVM. Okay, so system verilog means this will follow some C++ concept, that is nothing but OOP means what? Object oriented programming. Some classes will be there. So we can write, we can use verilog for test bench, but completely we cannot write. That is statically we can write, but dynamically we can write the test bench for system verilog and UVM. Okay, by using test bench we can test the verify the circuit whether you are getting proper, means where your design is correct or not. Okay, that is verification. And next, if design goals are met, okay, so yes means it will go to this next stage. If no means again it will go to the design stage. It will go to the design stage. Okay, and after that, logic synthesis. As I told you, logic synthesis. What is logic synthesis? Logic synthesis is nothing but what? After verification is design RTL designer is designed and RTL verification engine is verified. So logic synthesis is nothing but your design, RTL design, you are converting into what? Gate level netlist. Gate level netlist. Gate level netlist is nothing but what? Gate level netlist is nothing but hardware. Gate level netlist is nothing but what? Hardware. Okay, so hardware, that is nothing but logic synthesis, and DFT is nothing but design for test. Okay, design for test. So for this synthesis, gate level netlist, you will use some test vectors. You need to use some scan techniques, BIST techniques. Okay, so there you need to use, and you need to see the correctness of circuit for these test vectors. If you are giving this test vector 0 0 0, so I need to get this output. Okay, so that is nothing but DFT. DFT is nothing but design for testability. Okay, so there are DFT engineers are also there. Okay, so that means you need to see the job posting. So there are RTL engineers and there are DV engineers for verification. RTL engineers for designing, and DV engineers for verification, and synthesis engineers for making synthesis, and DFT engineers are for testing purpose. Okay, so DFT engineers are also there. Okay, and next there will be LEC, and there is, I told you, pre-layout STA. STA is nothing but what? Static timing analysis. Static timing analysis. Okay, so that means you need to know about, in the static timing analysis, basically you are dealing with the timing parameters like setup time, hold time, and delays. Okay, so what are the delays in the modules? Okay, so that that there in the static timing analysis. And if design goal met means it will go to the PD flow. Okay, what is the input for PD flow? Input for the PD flow is gate level netlist. Gate level netlist. Okay, and some parasitic extractions. Parasitic means what? capacitors, any capacitors or inductors are there, so we need to extract in parasitic extraction. And post layout static timing analysis, you need to do one more time static timing analysis. If design is met, again you need to do physical verification. So here physical verification engineers are also there. Okay, so after proving all these things, next you need to give this file. This is nothing but I told you, GDS file. Okay, so GDS file, GDS2 file. Okay, graphical design system GDS file to the fabrication. So they will take the input from the fabrication and they will do the there are some steps in the fabrication, there are some steps, so by using that steps, they will make the IC. Okay, this is ASIC flow. Do you understood this ASIC flow? Do you understood this ASIC flow, how we are making? Give response, so that I can move forward. Hello. Shall I move forward? Am I audible? Anyone give response? Hello? Yeah. So next you see, so there is floor planning. As I told you, floor planning means what you need to do. That means planning per your floor. And die size estimation. Die size is nothing but actually in the making of this die. So basically we will design means in the semiconductor, which one you are using, silicon or germanium? Anyone? Silicon or germanium? Silicon we are using. Why? Because silicon is abundantly available, and what we call, so the distance between this forbidden energy gap is around 0.7 electron volts. Okay, so for the silicon, and some important means so many steps came for the silicon, so that's why it is stable with the temperature. Okay, so die is nothing but it's like you can consider like IC or CD is there, no? That is nothing but die, we call as die. In that die we are fabricating all this whatever the CPUs, RAMs, and whatever the modules are there, we are fabricating in that. Okay, so that is nothing but die size. You need to estimate the die size, IO, macro. So IOs, where you need to place the IOs, input output, and where you need to see the macros. Okay, macro planning, you need to do planning of power distribution. Okay, and these are the goals of the floor planning. Okay, so all macros should be in place, placement grid, no macros should overlap. Okay, no PG nets, DRC, LVS. There are some violations are there, DRC, design rule check, and LVS violations. Okay, minimize the congestion, you need to minimize this congestion, make sure that design timing is meeting. Okay, there should be uniform core area. These are the goals of the floor plan. Okay, as I told you, what are the inputs for PD engineers? As I told you, so that means front end engineers, they will they will synthesize their code. So in the synthesis, they will generate the gate level netlist. Okay, so gate level netlist is the input for PD engineers. So that is nothing but what? Dot V. Okay, some constraints are there. Some constraints means what? You have timing constraints. Okay, and you have power constraints. Okay, you have area constraints. Okay, so these are the constraints you need to take care of. You need to minimize this timing, power, and area constraints. That will come under the constraints, that is .hdc. Okay, and there are some standard libraries are there, that is .library file. Okay, and physical library file is there, and again it is given to multiple voltage domain, that is UPF. Okay, so these are the inputs for PD domain, physical domain. Okay, physical domain, and this is floor planning full chip. Okay, so you have like so you need to estimate the die size by minimizing the core area. Okay, and core area for different IPs. What is IP? Tell me. IP means what? Intellectual property, no? IP is nothing but intellectual property. Suppose you have RAM, different. Suppose like example, like you have like MI phone. So mi phone mi phone will not create all this processor or dsp processor or display processor. All this it will not not it will not manufacture. So suppose if it is processor is there, means it will go to the Qualcomm and it will ask that I want this many specifications, and they will get the processor from the Qualcomm. Suppose processor is there, it will go to some other companies. So that means those are nothing but what, different companies are specialized in different modules. Okay, so those are nothing but we call as IPs. IP is nothing but intellectual properties. Okay, so they will take all this, they will assemble and they make as a module. Okay, so that is nothing but total product coming into the market. Okay, so we have planning, IO pads, power planning. Okay, you need to do for floor planning. Okay, and this is IO planning also you need to do. Okay, totally back end, this is back end. Okay, back end thing. Floor planning elements, you need to take care of core area. Core area means what, whatever the standard cells. Standard cells means what, standard cells means suppose standard cells are available in terms of what, suppose in terms of gates. Okay, in terms of gates and muxes, or if it is like sequential circuits, it is available in terms of flip-flops. Okay, so that means these standard cells are directly available from the company. Okay, so we can purchase these standard cells and we can fabricate in our die. Okay, these are nothing but standard cells. Okay, so means they will make the standard cells and they will make it available for universal use purpose. Okay, suppose if you want to design a shift register. Okay, so shift register means how many D flip-flops are required. So total 4 D flip-flops are required. So 4 D flip-flops means they will take 4 standard cells, that is nothing but 4 flip-flops, and they will do the connection and they will make a shift register. Okay, and suppose they want to make a counter, so they will take 40 T flip-flops. Okay, T flip-flops are already available in the standard cell. Okay, so that the design time or design cost or cost of making will decrease. Okay, so this is nothing but standard cell. And die area. Okay, this includes core area of IO cell. Okay, so next, placement, you need to place exact location. Suppose these are nothing but IOs, these are nothing but macros. Okay, this is die where I need to keep these modules. This is nothing but placement. Okay, so this is gives the exact location in core area to a standard cell is called placement. Okay, this is the definition for state placement. All instances of soft module will spread in core area at this stage. Placement goals are utilization of jump, no congestion, no overlapping, and good timing values. These are the placements goals. Okay, so why not just route the clock net all sequential elements just like any other net is. You need to do for timing, power, and signal integrity. Okay, this is clock tree synthesis. CTS you will get. Okay, in the PD you will get CTS, that is nothing but clock tree synthesis. And this is routing. Routing is nothing but what, connections. You need to do the wiring connections. Okay, so you need to involve creating global or track routes. Okay, connection made with signal pins, logical connectivity, routers. Okay, so this total comes in the routing. And next is sign off. Sign off is nothing but you need to do some verifications, physical verification. So that means physical verifications again 3 types: electrical, physical verification, and crosstalk and noise. Crosstalk and noise means what, should not one module should not interfere with other module, that is nothing but crosstalk. Okay, so in the electrical you have power estimations, IR drop analysis, power EM, signal EM. Okay, in physical verification you have LVS, DRC, antennas. Okay, some internal inbuilt antennas verification also there in the physical verification. Okay, and there should not be crosstalk. Okay, other checks should be there. After checking other checks you need to tape out. Okay, so this is nothing but sign off. Okay, this will get the sign off. Okay, so this is about the total physical design flow ASIC. Okay, in ASIC and ASIC flow. This is ASIC flow. Okay, and this is what is this physical design in the what are the parts present in the physical design. You have floor planning, IO planning, floor planning elements, placement, clock tree synthesis, routing, and sign off checks and physical verification. Okay, so this you are going to study in the core section. Actually, in order to go into this physical design course, first basically we will for first 2 months or 3 months we will brush up your concepts. First will teach digital. Okay, digital design. Okay, digital means basically number system, Boolean algebra, combinational and sequential, and FSM, that will teach. And after that you need to study about the basic PN junction diode, MOSFET, and CMOS. Basic electronics means electronics and CMOS fundamentals you need to have. Okay, so you need to have, and RTL designing also will teach, and DFT also will teach. Okay, that is comes under total basic subjects. Okay, after completing after 2 months or 3 months you will be allocated for correlated subjects. Okay, so this is about physical design. And next if you see, so about Gnanodaya VLSI technologies, we have premier advanced VLSI studies. Okay, so as I told you, this is located in two areas. One is in Bangalore and Hyderabad. So in Bangalore it is located in Martali. Okay, so best class in infrastructure and lab facilities are available. So trained faculties are 15 plus years both in industry and academics. Okay, 15 above 15 plus years industry, we will provide the training. Okay, with the trainers. So we have proven track record of placements with scholarship facility. Suppose if you good at basics. Okay, so at least if you clear 2 rounds, okay, so we will manage, and we try to place in good company. Okay, either it may be product based company or service based company. Okay, so what are the unique features of Gnanodaya VLSI? Means 100% placement assistance will be given. Okay, and industry standard course curriculum will be there. Okay, and we will give 24 by 7 support of lab support. Okay, so that is VPN based on the support. Okay, and compared to other institutes, we are providing low cost and value for money. Okay, we are providing for low cost PD for the PD. Basically some other institutes they will give like in the they will teach the PD in the synopsis tools, but we have the cadence tools. We will teach in Innovus, that too Innovus cadence Innovus tools we will teach. So basically if you see in the LinkedIn, most of the job description they are asking about the PD engineers which are having the exposure of Innovus tools. Okay, and VLSI technology is booming nowadays. AI technology is coming. So we are using this VLSI technology in healthcare, telecommunication, automotive industry, and consumer electronics. There is more scope in the VLSI technology, VLSI industry. There is more scope. Okay, so that means our India is also trying to set up own foundries. Okay, because during corona, so what happens? Actually we need to bring the ICs from China. Okay, so China stopped the import of this ICs. Okay, so due to stopping of import of ICs, there is means manufacturing of any automobile or healthcare or telecommunication, we got lagged. Okay, so after corona we realized that we should not depend on any other country. So we should have our own fabs and our own design industries. So Narendra Modi take an initiative, and he allocated some budget for VLSI industry. So we are booming. Okay, so by 2030 VLSI it will boom like anything. Okay, so this is the initial beginning step to enter into VLSI. Okay, career guidance and placements we are giving. Okay, so career guidance also, resume building also we are giving, and we are guiding how to how to be your profile in LinkedIn. Okay, will guide how to be your profile and how to contact with the industry persons, how to message, how to make the contact, and how to ask for referral. Okay, so we'll be give the all the placement related guidance. Okay, 100% placement assistance will be there. Okay, our placement process get requirement from the client, so we'll take the requirement from the client. Okay, what is the requirement? uh, so we will assist. So we'll guide the student to prepare resume as per requirement, and we will send the student resume to that client who are hiring. So we have many contacts with our HRs. Okay, anyway we are located in Bangalore, no, so many contacts are there. So shortlisted candidates will attend the written test and interview. After that final announcement will be given. Announcement of final selection will be there. 100% placement assistance we will provide. You cannot don't worry about the placement. First you concentrate on the gaining the knowledge on basics as well as core subjects. Okay, if you have knowledge, you can perform interview very well. Okay, uh, so gateway to the semiconductor industry in Gnanodaya. We follow simple but effective placement process. Give the clients for best students. So we will give the best students. We will make a inquiry about the company requirement. Okay, company provide the job description. Okay, and further we will provide eligible students. Okay, who are eligible. Parallelly, how we will select the eligible students means we will conduct a weekly test on Saturdays. Okay, that is assessment or assignment. Based on that we will take the merit list and we will provide the student to the company. Okay, so if you are performing very well in the weekly test, then there is a scope to be selected in the company. Okay, some company screens makes announcement of shortlisted candidates. After conducting both the written test, there will be written test, no, like they need to screen the candidates by using written test and interview. So these first two steps are nothing but they are checking for basic subjects. They are searching for basic before before going to core. First they will check for what basic subjects. Those are nothing but digital design. Okay, digital design, digital electronics or digital design, and basic electronics they will search. Okay, basic electronics and CMOS fundamentals. Okay, some Linux related commands. Okay, so Linux how we are there. Okay, and scripting also they will check. Okay, so you need to be strong in the basic subjects, then only you can clear this written test and interview. Okay, after that you can go to the core related round. Okay, core related round. Okay, so these are the gateway for semiconductor industry. So these are the top product based companies. Someone told Intel, no, Samsung, Intel, TSMC. Okay, Qualcomm, Nvidia. Okay, AMD, Infineon, Apple, ST. Okay, NXP. Okay, NXP is previously this is Philips. Now it is NXP. Okay, these are nothing but some product based companies. They will make the product. Okay, means Qualcomm is there. Qualcomm in mobile phones we are using Qualcomm Snapdragon processor, no, Qualcomm Snapdragon we are using processors, and most of the laptops they are making with the processors with Intel and AMD. Okay, the means the companies who will manufacture, means who will produce these products like microprocessors or SOCs or DSP processors. Okay, in our day-to-day life are nothing but product based companies. So service based companies means one second. Service based company, these are the service based companies. So as I told you, someone told what company, Tessolve. Okay, someone told, no, Tessolve, HCS. These are the, I think some companies, you know, L&T, Infochips, Mirafra, Graphene. Okay, and Capgemini, Wipro. Okay, Wipro has the VLSI division. Okay, Apex. Okay, Synapse, Sankalp Semiconductor, UST Global, Infochips, Selvitech, Chrysemi, Graphene. Okay, these all are nothing but what. So more than 1,000 plus service based companies are there. Okay, Those are located in Hyderabad, Bangalore, Noida, and all over the India. Okay. So this will give the service to the main product based companies. Okay. Suppose I told you know, like they want some other product based companies want some RAM. Okay. Some companies specialized in making the RAM. Okay. They will take the service from this. Okay. And they want some service like they want verification, or they want like designing. Okay. So they don't have the time, like they will take the service and they will make a MOU with the service based companies. Okay. So these are the list of hiring companies: Intel, Qualcomm, Sankalp, Synopsys. Okay, I think mostly you know, like Xilinx is not there. AMD acquired Xilinx now, so Xilinx is not there. AMD only. L&T, HCL, okay, Tissol, Questa, okay, Quest, Snaps, Smart SoC. I think these some companies you have idea. Okay, Moschip, okay, Altran, Infochips. Okay, these are hiring companies. Okay. And eligibility criteria is you should be graduated, should be BE, BTech. You can be a branch of ECE or EEE, ME, MTech. So that too in the specialization of VLSI and electronics. Okay. Minimum you have the percentage of 60% score in the graduation, and you should have the good communication skills. Okay. So communication skills are very much important. Suppose you need to express whatever you know. Suppose you have knowledge but you are not expressing, means how the interviewer will know whether you are having the knowledge or not. Okay. So that means English communication skills are must to crack the interview. You should have the good communication skills. You need to express whatever you know. Okay, whatever the knowledge you know, you need to express, then only the other person came to know that you know something. So if you are not opening your mouth and you are not saying, you are not expressing, how the interviewer will know that you know something. Okay. So you should be good at communication skills. You need to develop with your own, or you can go to some English, spoken English courses. Suppose if you are Telugu medium up to 10th class, like that you need to develop with your own. Okay. So training process, first there is a registration process. Okay, registration will be there. Okay, after registration there is a discussion in fee and course. Okay, so that means fee and course discussion will be there. Okay, so basically we have like PD. Okay, PD will have, and ASIC design is there, DV is there. Okay, as a DV is there, custom layout is there. Okay, analog layout is there. So we'll discuss about fee and course, and training period will be 6 months. Okay. So preparation with mentor support will be there. Conducting mock interviews, we'll conduct mock interviews weekly. Okay, weekly we'll conduct mock interview. 100% placement assistance will be there. So this is the training process, and the training methodology, as I told you know. So like these are the 3 specializations you have. Physical design duration is 6 months. Daily 1 hour class and lab practice will be there, 6 hours per week. Okay. Number of students, mainly we will take a maximum 20 students, 15 to 20 students. VPN lab access will be there. Okay, we'll give some IP VPN, based on that we can access, and 15 plus experienced faculty team are available, trainer as well as lab technician. 100% placement support will be there. Analog layout, this is for 4 months, and daily 1 hour class and lab session will be there, 6 hours per week, and 15 to 20 student intake. So VPN lab access will be available, 15 plus experience, and 100% placement will be there. So at DV I told you know, ASIC verification, this is front end. Okay, this is back end. Okay, this is nothing but back end. Physical design is back end. Okay, in VLSI, and this is nothing but front end. What we are doing, DV is nothing but ASIC verification. So we'll start from digital. Okay, digital, Verilog, system Verilog, UVM. Okay, so this is also 4 months, daily 1 hour class, 6 hours per week, and 15 to 20 students, and 15 plus experienced faculty are there, 100% placement. So for all these basic subjects are same. So first we will teach digital electronics or digital design, both are same. Digital design, okay, like number system, Boolean algebra, combinational circuits, sequential circuits, FSMs, serial adder, sequence detector, serial adder, Okay, and next we'll teach basic electronics, like what is diode and what is MOSFET. If you understand MOSFET, you can understand CMOS very well. Okay, so CMOS concepts, CMOS circuits. Okay, and what are the advanced CMOS circuits. Okay, and next after that we'll teach Verilog also. Verilog also you should have the knowledge, RTL coding. Okay, RTL coding, and also we'll teach DFT. Okay, those are the basic common subjects for all this physical design, analog layout, and ASIC verification. This is one more IC layout is there. IC layout means after this simulation, you need to do some layout. Okay, so layout people will do. Okay, layout will design this ASIC layout. Okay, so we need to, in the ASIC layout, we need to do see for checking this DRC, LVS, parasitic extraction. Okay, so this is nothing but ASIC layout. Okay, so this is fully developed analog layout. Okay, so ASIC chip design flow, same as I told you: specification, architectural design, RTL design, design verification, synthesis, converting whatever the RTL code into gate level netlist, and gate level simulation. Simulation means what? You need to check the way, you need to verify the circuit with waveforms. That is nothing but gate level simulation. Okay, design for test, DFT. Okay, test cases. Okay, and next floor planning, placement, clock tree synthesis, routing, sign off. Okay, sign off, GDS to fabrication, post silicon validation, and chip. Okay, so this is ASIC and chip. So this we already discussed. Okay, this we already discussed. Okay, this is ASIC design flow and specifications. So course fee is for physical design, analog layout, and design verification. The standard fee is 75,000. Suppose any college is giving some bulk of students, we can make MOU with the college, and we can give 5,000 discount, and we can give it for 70,000. That is MOU discounted. Okay, any college is ready to give some bulk of students. Okay, there we can provide some discount. Okay, these are the contact numbers of Gnanodaya VLSI Technologies. You can contact for admission, and you can mail okay, info@gnanodayavlsi.com, and this is the website. You can go through that, and what are the contents available, what are the courses available. You can go through this website and you can check. Okay, any questions? Any questions? Give response. Yeah, give response so that I can. Hello. Yeah, Vishnu. No. Okay. Deepika. Any questions you have? 1 second. I'll stop the recording.